Okay, so in this video, we're going to learn how to partition a segment. So at the end of the lesson, you should be able to answer the following question. How do you find a point on a line that partitions a segment in a given ratio? So basically, how do I find a point on a line that is 2/3 from the starting point? Okay, so what does it mean to partition a line segment? If you don't know, partition means to divide into parts. Okay, so if I want to partition something, I want to cut it into some parts. Okay, so for a line segment, I need to cut a line segment into parts. Okay, so we need to understand slope because we're going to be dealing with slope. So again, if you've got a positive slope, it's going uphill. If the line is dropping, if this little skier is going down the slope, you've got a negative slope. A slope of a 0 is a horizontal line, and then slope of up and down will be undefined. Okay, so just a quick review about slope. So now slope formula, hopefully you know it is y2 minus y1 over, I should say y1, over x2 minus x1. Okay, so let's review how to find the slope of a line. So again, the formula is y2 minus y1 over x2 minus x1. So x1, y1, x2, y2. So when I substitute in, I would have 6 minus a negative 3 over 4 minus a negative 2. I know two negatives together will give me a plus. So this becomes a 9 over a 6, which is going to reduce to divide each side by 3. 3 over 2. So the slope of that line would be 3 over 2. So 1, it's going up because it's positive, so we go up 3 over 2. Alright, so that's just a refresher on how to find slope. So now let's go back and include ratio. So remember, a ratio is a comparison of two quantities, and it can be written as a colon b, or as a fraction a over b, and it is read a to b. Okay, so those are the ways you can write a ratio. So let's talk about Connor. He's got some money in his wallet. So he's got a $1 $20 bill, 2 10s, 1 5, and 8 1s. So what's the ratio of $1 bills to $10 bills? So first off, $1 bills, I have 8 of them. I'm going to write it as a colon. And then how many $10 bills do I have? I have 2. So again, remember, that's the same as writing it 8 over 2, which I know can be reduced to 4 over 1. So the simplest ratio would be 4 to 1. So for every $4 bills that I have, I've got one $10 bill. Okay, so that's a review on how to write a ratio. What's the ratio of $10 bills to the total number of bills in his wallet? So I would need to add up my total number of bills. So 8 plus, that would be 10. So I've got 12 bills in my pocket. So the ratio of $10 bills, I have 2 $10 bills, and I have a total of $12 bills in my wallet. So again, that's the same as 2 over 12, which can be reduced if you divide the numerator and denominator by 2. You would get 1 over 6. So my ratio would be 1 to 6. So for every one $10 bill in my wallet, I have 6 of another dollar bill. Okay. So again, that's a quick review of ratios and how you would use them in the real world. But now let's talk about partitioning a line segment and take those two things into consideration. So point P is going to divide AB into the ratio of 3 to 1. So what does that mean? Okay, so it means I've got some line segment A and B, and I've got point P somewhere in there. It's probably not in the middle because it's in the ratio of 3 to 1. So it's going to be more towards point B, okay? Because I've got 3 parts, and then I have 1 part over here. Okay, so it's going to be closer to that B. So what that means is if you have 3 parts and 1 part, that means the whole line is consisting of 4 parts. Okay, so basically, to get your fraction, you're going to do the piece over the whole thing. So P is 3/4 of the way from A, and then P is also going to be 1/4 of the way from point B. So direction is going to be really important with this. We're going to have to figure out whether we're going from A to P or from B to P, okay? But that's how you change something to a fraction. So did you expect point P to be closer to A or B? And I told us that it's going to be closer to point B because it had to be further along the line. Because that 3 would make it farther from A. Okay, so if it had said the ratio of like 1 to 4, that would definitely mean point P would be somewhere over here, closer to A. Okay, so the bigger the number first, that's the farthest it is away. So how does the slope of AP compare with the slope of AB? Okay, well notice P is on the line, so the slope from A to P should be the exact same as the slope from P to B because they're on the same line. So they should have the same slope because they're on the same line. Okay, so I should only have to do the slope formula once, basically. Okay, all right, so let's look about how this is used in geometry. So I have a 32 foot long piece of rope that has a knot tied to divide the rope in the ratio of 3 to 5. So this actually kind of goes back to ratios and proportions. So I would expect it not to be halfway, but maybe right here. So it's got the knot, okay? Because this was 3 to 5, okay? The good thing is they gave us the whole thing, so I just need to figure out where that rope is. So I can say, not quite sure, but I know they're in the ratio of 3 to 5. So where should the knot be tied? If I set up an equation, 3x plus 5x equals the whole thing, and then combine like terms and divide by 8, we should get 4. So once I plug it back in, this distance would be 12. So you could say that knot should be tied 12 feet away from A, or you can also plug it back in here and get 20 feet and say that that knot should be tied 20 feet from B, okay? So either way, it depends on the direction, so whether you're coming from A or whether you're coming from B, but the knot should be tied somewhere in that location, okay? So let's look at normal lines on a grid. So the steps to partitioning a line segment. It's a little bit lengthy, but once you get the hang of it, it's not bad, I promise. So first thing you need to do is draw a picture, okay? Draw any kind of a line segment like I just did. Then you need to turn the ratio into, or the parts into a fraction. So sometimes they'll give you a fraction and say, hey, this is 3/4 of the way, or they'll give you a ratio. You need fractions before you can do anything. So make sure you change them to fractions if they were not given to you. You must find the change in the slopes. So you got to find the change in y and the change in x. Once you find the change in x and the change in y, you're going to multiply your ratio or your fraction by that slope and then add it back to your starting point. So if I'm starting at A, I'm going to find the slope, I'm going to find my fraction, and once I figure out how far I need to move, I'm going to add that back to the original point. Okay? Probably made no sense, but let's go over an example. Okay? Not going to lie, a little bit tricky. So find the coordinate of point P that lies along the directed line segment from A to B. So notice this is my starting point and I'm going over here. That partitions the ratio or the segment in the ratio of 3 to 2. So they gave me my ratio, 3 to 2. So what that means is this is 3 parts and this is 2 parts. Okay, so notice point P is closer to point B. So again, first thing I need to do is make them into fractions. So the whole thing would be 5, right? So this part is 3/5 of the way, and then this part is 2/5 of the way. Okay? So once you find your fractions, now I need to find my slope. So I need to see how did they go from B to A. So this will be my y, or my x1, sorry, because it's your starting point. In your y1, this is your x2 and your y2. So let me find the change in my x's first. Okay, so I'm going to do x2 minus x1. So I get 6 minus 3. So my change in x's were 3. Okay, and then I'm going to find my change in my y's. So I'm going to do y2 minus y1. Okay, so I'm going to say 10 minus 4 is a 6. So my x is changed by 3 and my y is changed by 6. Okay. The second thing you need to do, is it the third? It's the fourth. Okay. You need to multiply your changes by your fractions. So if I am starting at point A and going to point P, I need to use this 3/5. Okay. So I'm going to times my change in y and change of x by 3/5. Okay, so I'm actually going to write that down here. So my change in x's was a 3, and my change in y's was a 6. I'm going to times them by 3/5 because I was starting at point A. And decimals are fine in this case. So when I multiply 3 times 3/5, you should get 1.8. When I multiply 6 times 3/5, I should get 3.6. So basically, this is how much I need to move on the x's, and this is how much I need to move on the y's from my starting point over here. So what I'm going to do is I'm going to rewrite this point of a 3, 4, and I'm going to add 1.8 to the x's, and I'm going to add 3.6 to the y's. And so my new point should be my point P, which is going to be located at 4.8, 7.6. Okay? So this lovely point P up here is located from this point. Okay? Now that is all if I was coming from point A, my starting point. Okay? So I'm actually going to show you the opposite way and show you how you can go from point P to point A. So if you need to write this down, go ahead and press pause. But I'm going to show you the opposite way to prove that it makes sense. I'm going to show you what if I started at point B and went 2/5 of the way. Okay, so if now this is my start point, this is going to be my x1 and my y1 and my x2 and my y2. And I no longer need that because I'm going to use the 2/5 because I'm starting from B and figuring out how far to move. So the first thing you do is find your change in x's. So I'd say x2 minus x1. So that'd be 3 minus 6, which is a -3. Find your change in y's. So y2 minus y1, which is going to be 4, subtract 10, which will be a -6. So nothing changed except the negative signs, basically. So then multiply your change in x's and your change in y's by your fraction, which I'm now using 2/5. So when you multiply those two numbers, you should get -1.2 and then -2.4. So that's how far you need to move starting at point B. So now I'm going to use my point B, which was a 6/10. And I'm going to subtract, in this case, since they're negative, how far I should go. So when I do 6 minus 1.2, I should get 4.8, which is what I got in the other one. And then 10 minus 2.4, I would get 7.6, which is the exact same answer I got in the previous problem. Okay, so moving from A to P should be the exact same as moving from B to P. It just changes your fraction that you're using, and it changes how you set up your slope. Okay, so again, doesn't really matter which way you do it. Just make sure you start at the correct point. So go ahead and watch part 2 of the video. That'll go more in depth on these problems. But if you feel good, you're more than welcome to not. So thank you for watching example number 1. Alright, so in this video, remember, we're learning how to partition a line segment. So I'm going to go over 2 more examples, and then I'll allow you guys to try some on your own. So again, you're going to find the point Q along the directed line segment from point R to point S that divides the segment in the ratio of 2 to 1. So again, first thing I need to do is draw my line segment. So I've got R, and I have S. Okay, again, order doesn't really matter in this one. You can always draw your first letter on the left if you would like to. And the ratio is 2 to 1. So for every two parts, there is 1 part over here. So my total is going to be 3. So the second thing is to find your fraction. So this would be 2/3 along the way to point Q, and this will be 1/3 along the way to point Q. So now I need to find my change in Y and change in X. So I'm going to go ahead and write these points down. Alright, so I'm going to use R as my starting point. I always like to start on the left. Y'all could be different than me. This is my X1, my Y1, X2, Y2. So find my change in X's. So I'm going to do X2 minus X1. So I'm going to say 6 minus a -3. Which I know those will become a plus. So my change in X was a 9. Change in Y's is Y2 minus Y1. So my Y2 is -3. Subtract my Y1 was a 3. If I add those two together, I'm going to get a -6. Okay. Once you find your change in X's and change in Y's, you need to figure out what fraction to use. And since this was my starting point, to go from Q to R, I need to use my 2/3. So for my change in X's, I had a 9, and for my change in Y's, I had a -6. So I'm going to times those numbers by 2/3. Okay, 9 times 2/3 is a 6, and then -6 times 2/3 is a -4. Okay, so I need to add 6 on my X's and subtract 4 on my Y's from my starting point. So my starting point was a -3. So I'm going to add 6's to my X's and subtract 4. -3 plus 6 is a +3. And then 3 minus 4 is a -1. So that point, 1, -3, is where Q is. Okay? Makes sense because my X value is in between a -3 and a 6. And this -1 value is in between a +3 and a -3. Okay? So hopefully you feel a little bit better about this problem. Again, that's if you use the starting point to your left side. So let me do one more problem, and I'll actually start from the right side to help you guys out. So find the point Q along the line segment from R to S. So I have point R, I have point S. R is at -2, 4. S is at 18, -6, and it is in a ratio of 3 to 7. So I would expect point Q to be a little bit closer to R. So it's 3 parts to 7 parts. So first off, I need to find the fraction. So I know 7 plus 3 is 10, so that this fraction will be 3/10. And then this fraction will be 7/10. Okay? So now I'm actually going to start over here. I'm going to make this my starting point. And I'm going to go from an S to a Q. And I'm going to show you a little bit different way to look at this problem. So if this is my starting point, this is my X1 and my Y1, and my X2 and my Y2. So I'm going to find my change in X's. And do X2 minus X1. So -2 minus 18 will give me a -20. My change in Y's, it's going to be Y2 minus Y1. So Y2 is 4 minus -6, which I'll add those together and get a +10. Okay? So my change in X's, I need to subtract 20. My change in Y's, I need to add 10. So So now, since I'm starting from S and I'm going to Q, I need to use my fraction of a 7/10 this time. So I'm going to multiply those numbers by 7/10. And I totally don't have a calculator with me, so hold on. So we should get -14 for my change in x's, and then we should get +7 for my change in y's. So now I just need to add those back to my starting point. So if my starting point was at 18, -6, I need to subtract 14 and then add 7. So then my final point should be a 4, 1. Okay? So if we would have done all of that starting at point R, you would have gotten the exact same thing, but you would have used 3/10 and added that back to your original point. So it's up to you whether you want to start at the left point or whether you want to start at the right point. Just make sure you do the correct slope and make sure you use the correct fraction, okay? All right, let me know if you have any questions. Otherwise, you are going to try 1, 2, 3 problems on your own. I will give you a hint on this third one. They already gave you the fraction, so you don't have to do the part in the part, okay? So they actually did a step for you. So why don't you try these 3, press pause, and then we will go over them. So you try, you should have got the point 2.2 and 1.4. So again, label and draw a picture. You had 1/5 and 4/5. So I started at this point, I started at point A. So I did 7 minus 1 and got change of x's was a 6. 3 minus 1 was a 2. I used my fraction 1/5 because I was starting at point A moving this way. So my change in x was a 1.2 I needed to add, and then change in y was a 0.4 that I needed to add. Okay, so if you did not get this answer and you started from B, let me know and I can help you out. On the second you try, they gave you a graph, but I like this way better. So I drew my own little m to n, and so I had 3 parts and 2 parts. So I had 3/5 and 2/5. I started at point M, so I did y2 or x2 minus x1, and then y2 minus y1. So change in x was a 7, change in y was a 5. Okay, times them by 3/5. Got 4.2 for a decimal and then 3 for a decimal. So I added those back to my original starting point and got 1.2, 0. And what's nice is as you graph it, point P does look 3:2 ratio, which is cool. All right, last one. This one, I hope I didn't trick you up on it because they gave you the fraction. So you didn't have to do the 3 parts to the 1 part or whatever. So they gave you the fraction. So you had to use 3/4. So it was less work. So again, I started at point C. Oh no, go away. And I did -3 minus 6 and got -9 for change in x's, 4 minus -5 and got a 9 for change in y's. So I timed it by my fraction and got -6.75 and a +1. So I used my original point over here and subtracted and then added to my y's, and you should have got -0.75 and 1.75. So again, if you are confused at all still on this, or if you like to start on the right side, just let me know and I can definitely help you out. Otherwise, you have one small tiny thing to learn. If they give you an endpoint and a midpoint and how to find the other endpoint. And this is not bad, I promise. I saved it for the last. So first off, you have some endpoint, -9, 7, and then you've got the middle being 10, -3, and you are looking for the other point. Okay, what's nice is if the middle, you know that this piece is congruent to that piece, so you know they have the same slope. So this is kind of back to parallelograms and finding a missing point. But you ask yourself, how did they go from a -9 to a +10? Well, they added 19. So that's going to be true over here. And I'm going to add 19. So 10 plus 19 is 29. So that's one endpoint. Okay. And then How do they go from a 7 to a negative 3? They subtracted 10. So then I'm going to do negative 3, subtract 10, and get negative 13. And that's my other endpoint. Cool? Awesome. So you kind of just have to make sure that you find the distance and the slope from those. Okay? All right, why don't you try this one on your own? Let me know if you have any questions. Point 1412. So you had to figure out how to go from a negative 6 to a positive 4, which that was a distance of a positive 10. So make sure you do that to the other x's. Same thing, how do you go from a 4 to an 8? Well, you add 4 and make sure that happens again. Okay, so that's how you find an endpoint given an endpoint and a midpoint. Okay, so again, let me know if you have any questions on finding an endpoint or on partitioning a line segment. But thank you for watching, and let me know if you have any questions.